Right now, at this exact moment, your Toyota is bleeding. If you have found a dark, oily puddle under your engine, or if you have noticed that the entire lower half of your motor looks like it has been dipped in a thick coat of black grime, I need you to stop whatever you are doing and watch this video until the very end. Because what I am about to tell you is going to save you somewhere between $1,500 and $2,000, and it is going to expose one of the most quietly profitable misdiagnosis schemes running inside the automotive repair industry today. The mechanic who quoted you that enormous number is either completely incompetent or he knows exactly what he is doing and is counting on the fact that you are scared, that the puddle on your driveway is terrifying, and that you will hand over your credit card without asking a single question. I have been inside this industry long enough to know which one it usually is. The knowledge inside this video is the kind of thing that shop owners genuinely do not want circulating on the internet because it collapses a significant portion of their lower engine leak revenue in a single conversation. So let us have that conversation right now. Here's what the shop tells you. They get your Toyota up on the lift. They spend about 4 minutes looking at the underside of the motor, and then the service advisor walks out with a clipboard and a very serious expression. He tells you the lower oil pan gasket has failed. He tells you the factory sealant that Toyota used to seal the pan to the block has broken down completely and that oil has been weeping out of that seam for months and coating everything below it. He tells you the repair requires removing the front subframe to access the pan properly, that the job is 8 to 10 hours of flat rate labor, and that parts and fluids bring the total to somewhere around $1,500, sometimes more. He slides the estimate across the counter. The car is already on the lift. You have already taken the morning off work to get there. You are looking at an oily, disgusting engine and a number that makes your stomach drop, and almost everyone signs. But here's what is actually happening to your engine, and to understand it, you need to go back to a fundamental truth about how an internal combustion motor breathes. Your engine is not a sealed, static container. It is a dynamic, pressurized system that is constantly inhaling and exhaling. Every time those pistons fire and compress combustion gases, a small percentage of those gases slip past the piston rings and enter the crankcase, the lower cavity of the engine where your oil lives. Engineers call this blow-by. It is completely normal. It happens in every gasoline engine ever built. To prevent that pressure from building up inside the crankcase and forcing oil out through every seal and gasket in the engine, Toyota, like every other manufacturer, designed a crankcase ventilation system to route those gases safely out. That system manages the pressure. But the individual seals at every penetration point in the engine block, every tube, every sensor, every housing that pokes through the external wall of the motor, each of those penetration points has its own small rubber seal to keep that crankcase pressure from finding a path to the outside world. Now think about what happens to rubber when it lives directly adjacent to an engine that reaches operating temperatures of 200 degrees Fahrenheit, day after day, year after year, for 150,000 miles. The rubber does not stay rubber. The chemistry of thermal degradation is slow, but absolute. The polymer chains that give rubber its elasticity, that allow it to compress and spring back and form a perfect pressure seal, those chains begin to break apart. The material cross-links excessively, loses its plasticizers, and transitions from a soft, compliant gasket into something that behaves more like hardened plastic or brittle glass. A seal that was once perfectly conforming, filling every microscopic imperfection in the metal surface it contacts, becomes a rigid ring that no longer presses against anything. It simply sits in its groove, maintaining the approximate shape of a seal, while crankcase pressure finds the microscopic gap between it and the metal tube it was supposed to grip. That is exactly what is happening at the base of your Toyota's oil dipstick tube. The dipstick tube is a metal pipe, roughly the diameter of your finger, that drops straight down through the engine bay and inserts into the engine block at a point typically located near the lower portion of the motor, close to the exhaust manifold side of the engine. At the very bottom of that metal tube, right at the point where it disappears into the block, there is a small rubber O-ring seated in a machined groove. That O-ring is the only barrier between the pressurized interior of your crankcase and the outside atmosphere. When it is new and pliable, it creates a perfect seal. When it has been cooked by a decade of engine heat, it becomes hard and flat, and the crankcase pressure that is constantly looking for an exit finds exactly that, a clear path up the exterior wall of the dipstick tube and out into the engine bay. Here is where the visual illusion becomes almost perfect, and here is the precise reason that mechanics are able to charge $1,500 for a $2 problem. When oil escapes past that hardened dipstick O-ring, it does not drip cleanly to the ground and form a neat little puddle directly below the dipstick tube. Crankcase pressure pushes it out with intention. It coats the outside of the dipstick tube immediately, and then the airflow inside the engine bay, combined with the natural drainage behavior of oil on a hot metal surface, causes that oil to migrate. It runs down the side of the engine block. It spreads laterally. It drips onto the oil pan below it and coats the entire bottom surface of that pan in a thick, uniform layer of burnt, blackened oil. By the time you or a mechanic looks at it, there is a completely convincing visual presentation of a pan gasket failure, oil covering every surface of the lower block, a puddle on the ground beneath the pan, and absolutely no obvious single point of origin because the oil has had months, sometimes years, to redistribute itself across every surface it could reach. The mechanic who lifts your car and shines a flashlight at that mess is looking at evidence that, on the surface, perfectly matches a blown pan seal. And here is the critical piece of the deception. A legitimate diagnostic process would involve steam cleaning that entire lower engine, driving the car for a day, and then getting back under it with a fresh eye to find the actual origin point of fresh, wet oil. That process takes an hour, maybe two, and it costs you almost nothing. It would reveal the wet trail coming down the dipstick tube with total clarity. But that diagnostic process also reveals a $2 repair, and $2 repairs do not pay for shop overhead, technician wages, or the service advisor's commission. So the thorough diagnostic process simply does not happen. The visual evidence is declared sufficient, the clipboard comes out, the estimate is written. To understand why Toyota's design made this particular failure so invisible and so financially exploitable, you need to understand what happened to Toyota's engine sealing philosophy in the late 1990s. For decades, Toyota used traditional stamped steel gaskets with rubber beads to seal oil pans, similar to what every other manufacturer was doing. These gaskets were physical objects, pre-cut pieces of material you could hold in your hand, and when they failed, you could see the failure point clearly. But as Toyota pushed for tighter tolerances, longer service intervals, and lighter engine architecture, the engineering teams shifted toward FIPG, which stands for Formed-in-Place Gasket. This is an anaerobic liquid sealant, a silicone-based compound applied as a bead directly to the mating surface, which then cures and cross-links into a permanent, conforming gasket formed in the exact shape of the joint itself. FIPG technology was genuinely elegant. It eliminated the thickness variation of stamped gaskets, it self-adapted to microscopic surface irregularities, and it created an incredibly durable, long-lasting seal. On a properly built engine with clean mating surfaces, a FIPG oil pan seal will last the life of the vehicle. Toyota was proud of it. Here's what the dealership network understood that Toyota's engineers perhaps did not fully anticipate. When you shift to a sealing technology that is extremely durable and requires a specialized process to replace, and then you train a generation of service advisors to tell customers that any lower engine oil leak is a failed FIPG seal, you have created the perfect premium repair. The customer cannot see a gasket. They cannot hold it in their hand and say the gasket looks fine to me. The diagnosis is inherently technical, inherently inaccessible, and the repair is inherently intimidating. Subframe removal, oil pan separation, full degreasing, and a precise application of new sealant compound, a specific cure time. It sounds expensive because it sounds complex. And against that backdrop of real complexity, the $2 dipstick O-ring becomes completely invisible. Nobody in that ecosystem has any financial motivation to look at the simple thing first. Every financial incentive points toward the complex, expensive thing. Toyota dealerships built substantial revenue streams on this exact misdiagnosis through the 2000s and 2010s. Fleet operators, running large numbers of Toyota trucks, documented this pattern extensively. Companies running 20 or 30 Tundras and Tacomas for utility and construction work started comparing repair invoices and noticed that lower oil leak repairs were being quoted at identical, suspiciously round numbers across different shops in different states. When a few of those fleet managers started insisting on independent inspections before authorizing work, the pattern became undeniable. Steam, clean the engine, drive it, look again. Dipstick tube origin. Every time. New O-ring, 20 minutes of labor at most, and the leak is gone permanently. Those fleet operators started documenting and sharing their findings, and the information exists in commercial fleet maintenance records if you know where to look. The repair shops lost those fleet contracts. That is how seriously the industry took it. Not seriously enough to change the diagnostic protocol for retail customers, but seriously enough to avoid fleet operators who were paying close attention. So here is exactly what you are going to do today, and I need you to follow this precisely because the fix is so simple that if I do not make it concrete, you will not believe it will actually work. First, you need a single, new, rubber O-ring. The size you are looking for is typically a 22 mm outer diameter ring with a 2.5 mm cross-section. But the absolute safest approach is to take your Toyota to any parts counter, give them your year, make, and engine code, and ask specifically for the oil dipstick tube O-ring or dipstick tube lower seal. You can find this at AutoZone, O'Reilly Auto Parts, Advance Auto Parts, or any Toyota dealer parts department. The price will be between $1.50 and $3, depending on the brand. Buy two. They weigh nothing and cost nothing. Now park the car, let the engine cool for 30 minutes minimum, because you will be working near the exhaust manifold. Open the hood and locate your oil dipstick, the yellow or orange loop handle sticking up from the engine. Pull the dipstick out and set it aside. Now follow the metal tube that the dipstick slides into. Trace it downward toward the engine block. At the very base of that tube, where it enters the block, you will see a single bolt holding a small bracket or retaining clip that secures the tube to the block or to a nearby bracket. That bolt is a 10 millimeters. It is always a 10 millimeters. Remove it. Set it somewhere safe. With that bracket bolt removed, grab the metal dipstick tube firmly with both hands and pull it straight upward with consistent, steady force. It will resist slightly because the O-ring is creating friction, but it will release cleanly. Do not crank or twist it aggressively. Pull straight out. Once the tube is free, look at the very bottom end of it. You will see the old O-ring sitting in a machined groove around the tube. It will look flat. It will look hard. It will look almost like a plastic washer rather than a rubber seal. That is your culprit. That flat, hardened, completely failed ring is the source of the entire puddle on your driveway and every drop of oil coating the bottom of your engine. Peel it off with your fingernail or a plastic trim tool. Clean the groove with a rag. Take your new O-ring and apply a tiny film of fresh engine oil to it with your fingertip. Slide it into the groove. It should seat snugly and uniformly around the tube. Now reinsert the tube straight down into the block. Press it firmly until it is fully seated. Reinstall your 10 millimeters bracket bolt and snug it down, and reinsert the dipstick. That is the repair, under 5 minutes, under $3, permanent. Now clean the underside of your engine with an aerosol engine degreaser from any parts store. $4, rinse it, drive the car for 3 days, and then look under it again. There will be nothing. No fresh oil, no new drips. The lower engine will stay clean because the source of the oil was that single rubber ring, and that ring has been replaced. I want you to sit with that for a moment. $1,500 versus $3. 10 hours of phantom labor versus 5 minutes of real work. The subframe does not need to come out. The oil pan does not need to be separated from the block. The FIPG seal is almost certainly completely intact and will remain intact for another 100,000 miles. The only thing that failed was a rubber ring the size of a quarter that cost less than a cup of coffee, and the entire service industry built a revenue line around the fact that it looks exactly like something much more serious. They built this system on your fear and on your trust. They counted on the fact that you would see that oily mess and feel helpless and write the check. Share this video with every Toyota owner you know, because right now, somewhere in your neighborhood, someone is handing over $1,500 for this exact repair. Send this to them, not as a favor, as a financial rescue. Subscribe if you want to keep getting the information that shops pay very good money to keep out of your hands. And stay close, because next time I am going to show you the Toyota automatic transmission that shops are condemning as a total failure based on a single diagnostic trouble code. A transmission that a $16 filter and a fluid change will bring completely back to life. And I am going to tell you why the shop scan tool gives them every reason in the world to say it cannot be